record. Now I'm ready. Okay, today we're going to talk about the product rule and the quotient rule. So on Monday, everything we did had to be just constants times a function or functions added and subtracted together, right? We didn't do any examples of things where we had two functions multiplied or we had two functions divided. So that's what we're going to deal with today. How do you take a derivative if you have two functions multiplied together or you have two functions divided by one another? And what I want you to sort of remember about the derivative is that it can only act on one function at a time. So the derivative can only act on one function at a time. Just like when we did sums and differences, we just did what's the derivative of the first piece, what's the derivative of the second piece, what's the derivative of the third piece. The same thing is going to happen with the product rule and the quotient rule. So make yourself a note that the derivative only acts on one function at a time. Never on more than one function, okay? So when you're going to take the derivative of two functions multiplied together, your two functions could be a polynomial and a trig function, or a trig function and an exponential function, or a polynomial and a log, right? You're going to have two functions multiplied together. When you take the derivative, the way it's going to work is you're going to take the derivative of the first function and just leave the second function alone. And then you're going to ignore the first function because you've already taken its derivative and take the derivative of the second function. So the product rule looks like the derivative of the first function, f prime of x, leave the second function alone, just write it down, plus leave the first function alone because you've already dealt with him, times the derivative of the second. So you can always think of it in terms of these f's and g's if you want to. We're going to do some different ways. We're going to think of it in f's and g's and do the four pieces and then multiply them. And then we'll just do it sort of where we do it all at one step. But when you're thinking about it, you can say derivative of the first times the second plus first times the derivative of the second, or f prime g plus f g prime, whatever you want to do for your product rule. But it's always going to only do one derivative at a time. Notice it's not f prime g prime, right? It's f prime g, f g prime. Okay, so let's try one. This says find the derivative of this function. So it turns out you could have done this derivative before you learned the product rule, because you could multiply this out, right? Multiply 3x squared times both of these terms, multiply 2x times both of these terms, multiply -3 times both of these terms, and then take the derivative of each piece. There would be no more product anymore, right? You could multiply this out, get one big long polynomial, and take the derivative of each piece. It would be kind of tedious. You might make some algebra errors. So instead, what we're going to do is do the product rule. And in the product rule, I'm going to make this first set of parentheses 3x squared plus 2x minus 3, my f. And this second set of parentheses, my g. So in the product rule, I'm making this whole first set of parentheses, my f. And the second set of parentheses, my g. Okay, so I'm going to say f is 3x squared plus 2x minus 3. And g is x minus 1. Okay, notice in the product rule, I need f and g, and I also need what? F prime and g prime, yeah? Okay, so how do I find f prime if f is 3x squared plus 2x minus 3? Power rule, yeah. So bring the power in front, subtract 1 from the power, bring the power in front. Okay, so the derivative of f prime, is gonna be 3 times 2 makes 6x plus 2. Yeah. What's the derivative of g? 1. Great. Derivative of g is 1. Okay, all I'm going to do now is plug each of those four pieces into my product rule. Okay, so my product rule says the derivative of h is going to be f prime times g plus f times g prime. F prime is 6x plus 2, g is x minus 1, plus f, that's that 3x squared plus 2x minus 3, times g prime 1. So this is where I say again, you don't have to do any simplifying. You don't have to multiply that out. You don't have to combine any like terms. You can leave your answer just like that. When you take your quizzes on D2L, you're going to see answers like that. When you do your grade scope quiz, you can enter answers like that. You don't have to do any simplifying.
No, that's an equal sign.
That's an equal sign. Equals 6x plus 2 times x minus 1 plus 3x squared plus 2x minus 3 all times 1. So I didn't need to write down these 4 pieces, right? I could have just said, in this first set of parentheses, I need the derivative of f. In the second set, I need g. Here I need f. Here I need g. Whatever's going to get you to the right answer. Okay, so now we're going to do the quotient rule. The quotient rule is a lot like the product rule, except it uses subtraction. And if you start with a fraction, your answer in the end is probably going to end up to be a fraction. Okay, so when I do the quotient rule, I do it as bottom g times the derivative of the top f prime minus top f times the derivative of the bottom g prime, all divided by, because you started with a quotient, so you should end with a quotient, the bottom function g squared. If you notice that the numerator of this fraction is the same as the product rule, but with a minus instead of a plus, right? I just rewrote the order of those first 2 terms. I said g f prime minus f g prime. The words I'm saying in my head are bottom times the derivative of the top minus top times the derivative of the bottom divided by the bottom function squared. Okay, so let's try. And in this one, my f is going to be that numerator, 2x squared. And my g is going to be that denominator, 3x plus 1. You remember on Monday when we had a fraction, we were able to like just rewrite it and not have to use any special rules? How come I can't do that with this guy, but I could do it with the guy on Monday? Yeah, I got that plus 1, right? I can't do it if there's 2 terms in the denominator. The only time you can divide it up into multiple pieces is if there's only 1 term in the denominator. So because this denominator has 3x plus 1, if this denominator was just 3x or just 1, then I could have divided it up and not had to use the quotient rule. But when you have a bunch of things in the denominator, you're not going to be able to do anything but quotient rule. Okay, so f is 2x squared and g is 3x plus 1. Now I need to find f prime and g prime. What's f prime? 4x. Bring the power in front, subtract 1 from the power. Great. And g prime? 3. Good. Derivative of a constant times x is just that, constant. Oh, I'm doing a bad job with the recording today. I apologize to the recorded people. I forgot to share my screen. Go back up for a second.
So you said that for how you wrote the quotient rule on top, so you have to write it as like 2x f prime.
No, you can write f prime g. That would be okay too.
So you can write it like flipped or no?
So you can flip each term, but you can't flip the 2 terms themselves. Does that make sense? So like you could write it f prime g minus g prime f, but you can't do f g prime minus g f prime. Yeah, so you can flip within each term. You can flip the order that you multiply in, but you cannot change the order you subtract in. So it's important that your first term has the derivative of the top function. Okay, so then I'm just going to plug it into the y prime is gf prime minus fg prime over g squared. So y prime is going to be g 3x plus 1. Whoops. G bottom 3x plus 1 times the derivative of f 4x minus f 2x squared times the derivative of g, 3, all over the bottom function, 3x plus 1 squared. And I'm not going to do any simplifying. I'm going to leave it just like that, right? The less simplifying they do, the less algebraic errors I can make. So I'm going to leave my answer just like that and say, I'm done. There might become a time when you need to simplify, right? Like if you have to set it equal to 0, or you have to take a second derivative, then you might want to do some simplifying.
So you said that the
Yes. So the derivative of a constant times x is the constant, and then the derivative of the 1 is going to be 0. Yeah, because this is like a line with a slope of 3. So the derivative is going to be 3.
And same thing with the x minus 1, right?
Yeah, same thing with x minus 1. Yep, derivative of x, this is 1x. So derivative of x is 1, and then derivative of minus 1 is 0. Yep. Welcome. Okay, so here are 2 more. Why don't you take like 3 minutes and try to do the quotient rule one? S. I think that one's easier than the other one. So take 2 minutes and try to do the derivative of e to the t divided by t. Let me write down the quotient rule for you again. So take a second and see if you can find the derivative of e to the t divided by t. When you get an answer, check with your neighbor and see if theirs is the same. What's the derivative of e to the t? E to the t. Yeah, the derivative of e to the t is e to the t. You all. That's super. There's one girl in my first class.
Yeah.
It's yours is a regular iPad. This passion? Is yours the Pro too? Is that the 11-inch Pro?
Yeah.
I'm just going back and forth between like the, it's worth it for the Pro. Even more because it's less money.
It's like $200.
Like these choices are super fancy. You guys all have the same base. Like this all right from Apple. Yeah, because yours is the same as theirs. Yeah.
This case is
2 weeks, it's 2 weeks until my birthday. So I'm going to. I'll bring you a party.
That's the new trick.
Thank you. How do you know?
one of them's gonna be
See?
one. Derivative of t is
What is it? E to the t minus e to the t. I don't.
Hers are nicer than mine. Okay, how'd it go? What's the derivative of t? 1. Okay, all right. So s prime is going to be bottom times the derivative of the top minus top times the derivative of the bottom divided by the bottom function squared. So t e to the t minus e to the t times 1 over t squared.
I just put maybe instead of something like this.
Yeah. I got 1 because the derivative of t is 1. So in this case, I said f was e to the t, g was t, f prime, derivative of e to the t is e to the t, and g prime is going to be 1. The derivative of t is just 1 because this is a line with a slope of 1. Yep. Okay, let's talk about this one, this bottom left thing. What do you think you're going to need to use? The product rule. Yeah. The sine cosine thing. Yeah. And like it's something plus or minus something, right? So to take the derivative of this guy, you're going to take the derivative of x, which is 1, minus, then you're going to use a product rule. Yeah. So you see how intricate these things are getting? So what I'm going to do is over like to the side, I'm going to find the derivative of this thing. Okay, so I'm going to take a detour over to the side, and I'm finding the derivative of x cubed sine of x. So everybody take a detour over to the side and find yourselves the derivative of x cubed sine of x. You're going to need the product rule. Your first function is going to be x cubed. Your second function is going to be sine of x. So take 2 minutes and over on the side, find the derivative of x cubed sine of x.
Is this right?
That's so very close to right. And like you make the error that everybody's doing. That minus here goes with this whole derivative, right? So like put this guy all the way down. Or make sure you don't minus.
Is it sine?
That's
Is it 2 sine?
who remembers the derivative of sine of x?
Cosine.
Cosine x. The derivative of sine of x from last time was cosine x.
That's right, I got 2 sine cubed x plus cosine.
We have an audit term on September.
Maybe you don't do
Ooh, remember you gotta use the product rule, because this is x cubed times sine of x. So make f be x cubed and g be sine of x. You guys did the whole thing. You just did that part. Good. Okay, how's it going? What'd you get for the derivative of this guy? Derivative of the first, 3x squared, times the second, sine x, plus derivative of the, leave the first alone, x cubed, times the derivative of the second, cosine x. Yeah? Everybody okay? So my first function f was x cubed. My second function g was sine of x. I did f prime g plus f g prime. Okay, that's gonna go in for the derivative of that yellow stuff. So when I find y prime, I'm gonna say the derivative of x is 1. The derivative of x is 1 minus, and now I'm gonna put a bunch of parentheses. And the reason I'm gonna put a bunch of parentheses is because whatever the derivative of the yellow stuff is, all gets subtracted. So minus all of this stuff, because that's the derivative of that yellow function. 3x squared sine x plus x cubed cosine x. I can leave it just like that, right? If you'd rather, you can distribute that negative sign with the negative here and the negative there. One minus 3x squared sine of x minus x cubed cosine x. But don't forget those parentheses, right? Because if this guy doesn't turn negative, then I don't have the right derivative. Okay, here we go. I know this was a late edition. I'm sorry. If you printed already, I decided we needed a late edition. So just turn over your paper and write this one on the back. This guy says, find the derivative of this function. X squared minus 1 times 3x cubed minus 6x plus 5, all divided by 8x minus 7. So this was my late edition. X squared minus 1 times 3x cubed minus 6x plus 5, all divided by 8x minus 7. Okay, tell me what you notice about this function. Yeah, there's a quotient, right? Because I have a fraction there. But the numerator of this function has a product in it. You see that? So to find the derivative of this guy, I'm going to have to use both the product rule and the quotient rule. Okay, to find the derivative of this guy, I'm going to have to use both the product rule and the quotient rule. When I think about it, my two functions, my top function is x squared minus 1 times 3x to the third minus 6x plus 5. And my bottom function is 8x minus 7. So my top function, f, is x squared minus 1 times 3x cubed minus 6x plus 5. And my bottom function, g, is 8x minus 7. So when I'm doing the quotient rule, I need gf prime minus fg prime over g squared, right? So I've labeled f and g. Now I'm going to find f prime, and I'm going to find g prime. G prime's the easy one. What's the derivative of g going to be? 8. Derivative of g is 8, right? The number times x, derivative is just a number. Derivative of negative 7 is just 0. So g prime is going to be 8. In order to take the derivative of f, I need the product rule. Dun, dun, dun. Okay, product rule says derivative of the first 2x times the second plus first times the derivative of the second 9x squared minus 6. Okay, so for f prime, I say derivative of the first 2x times the second 3x cubed minus 6x plus 5 plus first x squared minus 1 times the derivative of the second. Bring the power in front, subtract 1 from the power, minus 6. So in my formula up here for f prime, I'm going to put this whole thing in my quotient rule formula for f prime. I'm going to write that whole piece. Y prime equals bottom 8x minus 7 times the derivative of the top. I'm putting some brackets there because I got to write that whole blue thing. 2x, 3x cubed minus 6x plus 5 plus x squared minus 1 times 9x squared minus 6 minus, man, I don't have enough room. Let me start again. I'm going to write smaller this time. You need a lot of space. Okay, I'm going to go all the way. Okay, I got this. Minus, okay, so top, which was x squared minus 1 times 3x cubed minus 6x plus 5 times the derivative of the bottom, 8, all divided by g squared. Yeah. We got the derivative of f by using the product rule. So the two functions were this 3x cubed minus 6x plus 5 and x squared minus 1. So this guy was the derivative of the first and the first. And this guy was the second and the derivative of the second. And yeah, just make sure you use parentheses correctly and it'll still come. Yeah, it's got a pretty good engine behind it checking your answers. Yeah. So make sure you don't miss these parentheses right here, the ones that I have as the hard brackets there. Make sure you don't miss those. Otherwise it'll, that 8x minus 7 won't get to everybody. Yeah. We don't have to do anything to that. Yeah. You could if you wanted to, but you don't have to. I wouldn't. I would just get it wrong if I tried to do something. Okay, what we're gonna do now is I have this like quiz. Oh, a total score out of 10. We should make it out of 8. Okay, on this quiz, it's not, you're not doing a quiz, okay? On this quiz are 4 questions and 4 answers. What you're gonna do is you're gonna mark each answer out of 2 points. If you think they're completely and totally wrong and they did nothing right, you should give them a 0. If you think they did something right, but it's still not all right, give them a 1. And if you think they're like, it's a perfect answer, give it a 2. So at the top, you should have a grade out of 8. If they're totally wrong or wrong, you should find the correct answers on the side, okay? So with your neighbor, you're gonna make a score out of 8 at the top of this, and you're gonna try to figure out have they gotten it right or not, okay? That's what the grade this is. So it says to give them a score out of 10, but you're just giving a score out of 8. So each problem can have 3 scores, a 0, a 1, or a 2.
Are you supposed to each take one?
Yeah, each take one. And so you can write on it.
So the best score is the 1?
The best score is a 2. Yeah, if it's totally right, give it a 2. If it's partially right, give it a 1. If they've done like complete gibberish, give them a 0, okay? So you can each take your own.
Oh, I thought you said take 1.
No, you can each take. Okay. Bye, recorded people. I'm sorry, I forgot to share the screen in the beginning.
3x